windswept hill at Kitty Hawk, man sprouted wings. And if a soaring granite spire at Kitty Hawk is a memorial to the birth of the air age, so too is the soaring steel gantry around the spacecraft, mounted on an Atlas rocket at Cape Canaveral, the symbol of the dawn of the age of man's flight in space. December 17, 1903. On that eventful morning, who could have foretold what the conquest of the air would eventually mean? And 57.5 years later, who among the millions watching and listening around the world could foretell the implication of free man's breakthrough into space? For the moment, it was enough that he was going. Astronaut Alan B. Shepard in a Mercury spacecraft called Freedom 7, May 5, 1961. Saw the Earth from a height of 100 feet. Alan Shepard saw it from 100 miles. And just as the first flights at Kitty Hawk proved that man could fly in the air, so did the first Redstone-powered flights in Mercury spacecraft prove that man could travel through space. Short ballistic flights downrange by Shepard and by astronaut Virgil Grissom were proof. But they were also only preludes. Preludes to orbital flights around the Earth. February 20, 1962. Astronaut John Glenn in a Mercury spacecraft called Friendship 7. The mission? Orbit. Proved the spacecraft could sustain life in orbital flight. Proved that man could operate effectively in space. The voyage of Friendship 7 proved that man could operate as a pilot in space. But Friendship 7, too, was only a prelude, only the end of the beginning. Now it was time to put man to work in space. Astronaut Scott Carpenter would take the next step in a Mercury spacecraft he named Aurora 7. Carpenter would make new scientific observations from space for the benefit of all mankind. He would use Aurora 7 as a platform for science, for star observations, measurements of star brightness in space, using a specially designed photometer, measurements of the relative brightness of zodiacal light and other dim night phenomena, using a special instrument with crossed Polaroid filters. This instrument also permits direct viewing of the sun's disk and measurements of the polarization of the sun's corona, measurements of light attenuation through the atmosphere, and more than a dozen other astronomical and physiological experiments. Experiments that cannot be performed on Earth. Carpenter would also make observations and photographs of the booster falling away to investigate the visual limitations associated with a receding object in space. Color perception by releasing a multicolored balloon, then observing and photographing the balloon to determine its color reflectivity and aerodynamic behavior, both of which have a bearing on visual aspects of future rendezvous missions in space. Photographs of the Earth's horizon to be taken through special filters for scientific study by the Massachusetts Institute of Technology and the U.S. Naval Research Laboratory. Photographs of cloud masses over the Earth for study by Weather Bureau scientists. A special experiment carried on board the Aurora 7 would investigate the behavior of fluids under zero-G conditions. Throughout the flight, Carpenter was scheduled to conduct spacecraft maneuvers using the manual control system. man went to work in the air after Kitty Hawk, so too now, man is going to work in space.